Good evening, and welcome back to SleepWise. Tonight, we begin with something simple. The quiet realization that everything around you, everything you touch today, is made of a small set of fundamental pieces, elements on a periodic table. But before we drift further, a gentle reminder. If these stories help you rest, please follow the show and share an episode with someone who might need a softer night. Now, let the room settle. The air is still, the light is low. Somewhere beyond the walls, the world continues its restless motion, but here we move more slowly. Today was ordinary. You breathed, you drank water, you held a cup, opened a door, checked your phone, walked beneath the sky. Nothing remarkable. And yet, beneath each of those small gestures, something ancient was present. The air you breathe is mostly nitrogen, a calm and steady gas that fills the space without asking for attention. Mixed within, it is oxygen, more reactive, more eager, quietly supporting each breath, moment after moment. In the glass of water beside your bed, two elements rest together in perfect simplicity. Hydrogen, the lightest of all, bound to oxygen, forming something so familiar that we rarely pause to consider it. The metal of a spoon, cool and reflective, carries iron at its core, strengthened by other elements that help it resist the slow bite of rust. Your phone, dark now and waiting, contains silicon shaped from sand, lithium storing energy, and copper guiding currents along silent paths thinner than a hair. In all of these, elements were present. An element is one kind of atom, defined by the number of protons in its center. Change that number, and you change the identity entirely. Keep it the same, and you preserve something constant across the universe. Hydrogen here is the same hydrogen that formed soon after the universe began. And iron, whether in a spoon or in your blood, was forged in the deep interiors of stars, long before the earth cooled. The periodic table is not merely a chart. It is a quiet inventory of existence. For centuries, people gathered substances the way you might gather small stones at the edge of a shore, turning them in the hand, noticing weight and color, glow and scent. Over time, patterns appeared, and in the 19th century, a careful arrangement took shape, with blank spaces left for elements not yet found, as if the table itself could sense what was missing. Tonight, we will not study it as students. We will notice it as it appears in an ordinary day, moving gently from morning breath to evening stillness. Nothing to memorize, nothing to retain. Only the comfort of recognizing that the world, in all its complexity, is built from a small, orderly collection of pieces. The world slows, and so do we. And so we begin. The morning air feels like it has a texture, even when you cannot name it. It cools the inside of your nose. It slips in and out with a rhythm you do not have to manage, and it seems almost empty, as if breath is made of nothing at all. But the air is not nothing. Most of it is nitrogen, a quiet presence that makes up close to 4/5 of the atmosphere. Nitrogen is content to drift and linger, to cushion the world without reacting much, like a soft background note in a long piece of music. Oxygen is there too, a smaller portion, but far more involved. Oxygen is the part that joins in, the part that helps release energy, the part that makes fire possible, and that allows your cells to do their slow, steady work while you rest. When you inhale, you are not taking in air as a single thing. You are taking in a mixture, a gentle crowd of different elements and compounds moving together like a calm tide. An element, at its simplest, is a substance made of one kind of atom, and an atom is a tiny unit with a center and a surrounding haze of motion, as if a small dense heart is wrapped in a soft cloud. In that center are protons, and the number of protons is what makes an element itself. 1 proton is hydrogen, 2 is helium, 7 is nitrogen, 8 is oxygen. It is a quiet rule, steady as counting. This is why the periodic table feels like a map. Each element has a permanent address, not because humans decided it should, but because the universe is built on these small, consistent identities. And yet, you do not need to picture a chart tonight. You can picture your breath, nitrogen mostly, steady and unbothered. Oxygen, enough to matter, enough to keep the inner world of your body lit, not with flame, but with metabolism, with warmth, with life. You exhale, and that oxygen has changed its story. Some of it has paired up with carbon to become carbon dioxide, a molecule you release without effort, carrying away what your body no longer needs. Even in this simplest act, the elements are meeting, separating, combining, and moving on. Outside, the same air brushes over trees and rooftops, over desert sand and distant water, over cities and open fields, endlessly circulating. And inside, in your calm, ordinary breath, the day begins to reveal its hidden inventory. Long ago, people tried to name what they could not see. Some spoke of airs and vapors, of invisible spirits that fed flames or put them out. In the late 18th century, careful experiments began to separate the mixture, to show that air was not a single substance at all. The names we use now, nitrogen and oxygen, are calmer than the old guesses, but they carry the same human wonder that even emptiness has structure. Tonight, you can let that wonder be soft. The air holds you, and you do not have to hold it back. A little later, water appears, the way it always does, without ceremony. Maybe it is a glass beside the sink, or the first sip you take without thinking, or the rinse of your hands as the day truly starts. Water feels simple. It is cool, it is clear, it carries no obvious label, and yet it has a precise identity that never changes. Wherever you find it on Earth, the basic pattern is the same. 2 hydrogens, 1 oxygen. Hydrogen is the lightest element of all, a single proton at its core. It is so light, so eager to drift, that in the open emptiness of space it can spread into a thin mist, gathering slowly into clouds that one day become stars. Oxygen is heavier, more inclined to join with others, and on our planet it is a quiet architect. Oxygen bonds easily, shaping minerals, shaping water, shaping the chemistry of living things. When hydrogen and oxygen meet in just the right way, water forms, and the result is not a compromise, but something new, with its own softness and strength. You can feel that difference in your own senses. Water is not explosive like hydrogen, and it is not fiercely reactive like oxygen. It is steady, soothing, and dependable. In a way, it is a reminder that the world is not only made of elements, but of the relationships between them. The same water that fills your glass has been circulating for a very long time. It may have drifted through clouds, fallen as rain, moved through soil, traveled underground, and returned again, slowly, through rivers and pipes and reservoirs. It carries tiny traces of other elements along the way. Calcium and magnesium can make it feel hard, leaving faint marks on kettles and faucets. A hint of iron can tint it, and a hint of sulfur can change its smell. But beneath those small differences, the main shape remains. HHO. And if you picture those letters, let them stay gentle, like initials written in the corner of a page. Water is a daily element story you repeat without noticing. You lift the glass, you swallow, and your body receives it with quiet gratitude. It becomes part of your blood, part of your cells, part of the thin film that keeps your eyes comfortable, part of the moisture in your breath. Then, later, it leaves again, returning to the world. Nothing dramatic, just a calm cycle, carried by simple atoms that have been here in one form or another, since long before anyone had a word for them. Sometimes you meet water in other moods. As ice, it becomes quiet and firm, making a thin crackle in a glass. As steam, it turns invisible again, rising in soft warmth from a cup. The atoms do not change, only their spacing and their pace, as if the same travelers have chosen to stand close together or to drift apart. And all of it begins with that small, steady trio, 2 light hydrogens and 1 patient oxygen. Breakfast has its own quiet chemistry. The sound of a knife against a plate, the soft crumble of toast, the small twist of a grinder, the familiar reach for salt. Salt looks like nothing more than white grains, but it is one of the clearest examples of how elements can change their nature when they come together. Sodium, on its own, is a metal that reacts quickly. It is so eager to give away what it holds that it can fizz and flare in water. Chlorine, on its own, is a gas that can sting the throat and eyes, sharp and unpleasant in high concentration. And yet, when sodium and chlorine meet in the right ratio, they become something stable, something safe, something we sprinkle without fear. a crystal, calm and clean. In salt, the elements arrange themselves into a repeating pattern, like a tiny city made of alternating partners. Each sodium sits near chlorines, each chlorine near sodiums, and the structure holds, grain after grain, in a quiet order that feels almost architectural. If you have ever noticed how salt catches light, how it can sparkle briefly, that is the shape of its crystal speaking. It is not magic. It is geometry repeating itself. And then there is taste. A small pinch on food can wake up flavors, not by adding much of its own, but by helping your tongue notice what is already there. Sodium ions, tiny charged fragments, are part of how your nerves send signals. They help create the little electrical differences that let taste become a message. So, even as you season breakfast, the same element is working inside you, helping your body translate the world. Somewhere nearby, perhaps, there is a bowl of fruit. Potassium, another element related to sodium, sits quietly in bananas and oranges, and in the muscles that carry you through a day. Potassium and sodium move like a pair in the background of life, trading places across cell walls, keeping the inner environment balanced, steady, and calm. You do not need to track any of this. You only need to know that the ordinary act of adding salt connects your plate to the periodic table and your tongue to the silent flow of atoms. A breakfast table, in its own way, is a small laboratory. But it is also just a place to sit, a place where the day feels possible, and where the elements, once again, hide in plain sight. For most of human history, salt was precious enough to travel long distances, carried along desert routes and overseas. It preserved food through seasons. It shaped trade, and it even shaped language in small echoes that remain in words for pay and value. All from two elements that, alone, can be unruly, but together become dependable. Tonight, you can let that dependability be a comfort. Small grains, small rules, a steady world. The spoon is a humble object. It rests in a drawer. It clinks softly against other utensils. It carries soup and tea and small tastes from bowl to mouth, and it rarely earns a second glance. But if you hold it for a moment, you can feel its cool certainty, and you can imagine the elements inside it, standing together like a well-trained team. Many everyday spoons are made from stainless steel. Steel begins with iron, an element that humans have worked with for thousands of years, pulling it from rock, heating it, shaping it into tools, nails, hinges, and the quiet skeletons of buildings. Iron alone, however, has a weakness. Given enough time and moisture, it rusts, surrendering to oxygen in the air, turning reddish and rough, as if it is slowly returning to the earth. To make steel that resists that change, other elements are invited in. Chromium is one of the most important. When enough chromium is present, it helps form a thin protective layer on the surface, so subtle you cannot see it, yet strong enough to slow the march of rust. Nickel is often there as well, adding toughness and helping the metal keep its smooth shine. These elements do not make the spoon loud or complicated. They make it calm. They let it stay itself through years of washing, through heat, through the ordinary wear of daily use. And while the spoon feels simple, its story stretches back through time. Iron was once made in the cores of massive stars, under pressures we can barely imagine. When those stars ended, they scattered their heavier elements outward, seeding space with the raw material for planets, oceans, and eventually kitchens. So, when a spoon taps the edge of a mug, it is not only a sound of breakfast, it is a small echo of stardust. There is another quiet connection here. Iron is not only in spoons and beams, it is in you. A trace of iron sits inside hemoglobin, the molecule in your blood that carries oxygen. With each breath, oxygen binds and releases, and iron sits at the center of the exchange, steady and reliable. It is strangely comforting to think that the same element that helps a spoon keep its shape also helps you move through the world. Tonight, we are not trying to remember a list. We are simply noticing. A spoon, a breath, a quiet strength. Even the word steel hints at mixture. A small amount of carbon, another element, slips into the iron and changes how it behaves, making it harder, more resilient. Sometimes manganese joins too, helping the metal stay workable as it is formed. These are tiny percentages, small presences, yet they shape the feel in your hand. So when you rinse the spoon clean, water running over it, oxygen floating above it, you are watching several element stories crossing paths in a sync. Light gathers at the window in a thin, quiet way. Even if the day is cloudy, even if the sun is still low, a window knows how to borrow brightness and spread it softly across a room. Glass feels like it should be simple, almost like frozen air, but it is a careful arrangement of elements made steady by heat and time. At its heart is silicon, an element that begins as common sand. Silicon is everywhere on Earth, tucked into rocks and beaches, into dust on shoes, into the pale grains that slip through fingers. When silicon binds with oxygen, it forms a structure called silica, and in nature, that structure becomes quartz, flint, and countless minerals hidden in hills and deserts. To make glass, people learn to melt sand at very high temperatures, then cool it in a way that keeps it from settling into crystals. The atoms become a kind of held motion, a solid that remembers it was once a liquid. That is why glass can be clear. The structure is irregular enough that light passes through without being scattered the way it is in many crystals. Often, other elements join the recipe to make the melting easier and the final material stronger. Sodium from soda ash helps lower the temperature needed, and calcium helps the finished glass resist dissolving in water. So even your window carries a small community of elements, cooperating quietly, so you can see the world. You might look through it and notice nothing but distance, buildings, trees, a strip of sky, But the window itself is a thin sheet of ancient chemistry, a human-made stone that lets light travel. And there is a gentle connection between this and the phone you'll notice later. Silicon, when treated carefully and combined with other elements in tiny amounts, can guide electricity in controlled ways. In glass, silicon is content to be still and transparent. In a microchip, it becomes a pathway for thought-like signals, moving at speeds too fast to feel. Tonight, you don't need the details. You only need the quiet comfort that the same element can be both sand and screen, both window and circuit, depending on how it is arranged. For now, the window simply holds the morning. Light comes in, the room brightens a little, and the day continues, built from atoms that have been here all along. If you like, imagine the window as a quiet border between two worlds. On one side, the busy day. On the other, this slow room where light arrives without needing to be chased. And when you turn away from it, the glass keeps doing its one quiet job, holding space for light, letting the outside world remain outside while you stay here, unhurried. The table beneath your hands, the wooden door you pull closed, the pencil on a page, all of them share a gentle foundation. Carbon. Carbon is an element that feels almost shy because you rarely meet it as carbon in pure form. Instead, it appears as living things, as wood and cotton and paper, as bread and fruit, as the soft structure of your own body. What makes carbon special is its talent for connection. Carbon atoms can link to other carbon atoms in long chains, in branching patterns, in rings, in shapes that can be simple or endlessly complex. This is why carbon sits at the center of life's chemistry. It is not the only element that matters, but it is one of the best at building frameworks, like a patient builder stacking blocks into stable forms. In wood, carbon is part of cellulose, long molecules woven together like invisible fibers. Those fibers give the grain its strength, and they help the tree stand through wind and time. If you listen closely, wood has its own sound. A soft creak as you lean on a chair, a dull knock when you tap a tabletop, a low warmth compared to metal's cool ring. That warmth is partly the way wood holds heat, and partly the way its structure traps tiny pockets of air. Even the scent of wood, faint and earthy, comes from carbon-based compounds slowly releasing into the room, a quiet reminder that this material once grew toward the sun. Carbon can appear in calmer, darker forms too. In charcoal, it is the leftover skeleton of wood after heat drives away water and other elements. In graphite, it becomes the smooth darkness of a pencil line, sliding across paper in soft, whispering strokes. And in diamond, carbon forms a tight, bright lattice, hard enough to scratch glass, clear enough to hold light, all from the same element, arranged in different ways. This is another theme you can carry with you tonight. Elements are few, but their arrangements are many. Your ordinary day is full of carbon in the food you ate, in the fibers of clothing, in the skin that feels the air, in the wooden objects that quietly support your life. And beyond Earth, carbon is a traveling element. It forms in stars, it drifts in cosmic dust, and it appears in the faint chemistry of distant clouds, as if the universe enjoys building with the same pieces everywhere. For now, carbon remains simple. It is the quiet backbone of the ordinary, holding your morning together without asking to be seen. And when evening comes later, carbon will be there again, in the small flame of a candle, in the warmth released from food, in the soft carbon dioxide you breathe out. It follows you through the day like a gentle thread, unbroken. Later in the day, you may stretch without thinking, or stand up a little straighter, or feel the quiet weight of your own body settling into its shape. Beneath skin and muscle, beneath warmth and breath, there is an inner architecture that holds you up. Calcium. Calcium is an element that prefers to become part of structures. In nature, it forms chalk and limestone, the pale bones of ancient seas turned into rock, the white cliffs that catch sunlight, the shells that once protected small creatures in shallow water. In you, calcium is a steady presence in your bones and teeth. It helps build a framework that is both strong and living, not fixed like stone, but constantly renewed. Bone may feel permanent, but it is always changing. Your body breaks down small parts and rebuilds them, replacing what has worn away, adjusting to stress and movement, keeping the structure reliable over years. Calcium works with other elements here too. Phosphorus joins in to form hard mineral crystals, giving bones their firmness. Collagen, made mostly from carbon and other elements, provides a flexible scaffold, so bone can be both tough and slightly springy. It is a quiet engineering solution, strong but not brittle, supportive but not stiff. If you have ever noticed the sound of your own steps, the dull thud of feet on floor, that sound travels through bones as vibrations, gentle messages of contact and balance. Calcium also has another role, one that is softer and more temporary. Tiny amounts of calcium ions move in and out of cells as signals. They help muscles contract and relax. They help nerves communicate, and they help the heart keep its calm, repeating rhythm. So, calcium is both structure and signal, both framework and whisper, and it begins in the world outside you. Calcium enters the body through food and water, through leafy greens, dairy, small fish, or fortified grains, and then it is guided carefully into place. Your body manages it with patience, storing some, releasing some, keeping the levels within a narrow range, as if it knows that steadiness is part of comfort. Tonight, you do not need to remember numbers or pathways, just this calm idea. There is an element in you that once shaped seashells and cliffs, and now it holds you upright, quietly, while you move through an ordinary day. Even rest has a structure. Even sleep is supported by the steady architecture of calcium. Sometimes, if you press your tongue gently against a tooth, you can feel how solid it is. That firmness is calcium's quiet signature, held in place through years of ordinary use. In the middle of the day, without any announcement, you take another breath and another, and your blood continues its silent work. It moves warmth to fingertips, carries nutrients, collects what must be carried away, and keeps your inner world steady. Inside that flowing system, there is a small element doing a very specific job. Iron! Iron is not plentiful inside the body, not in the way water is plentiful, but it is crucial. A tiny amount, placed in the right molecule, makes a vast difference. That molecule is hemoglobin, a protein in red blood cells. Hemoglobin holds iron at its center, and iron has a talent for binding with oxygen. Not too tightly, not too loosely, just enough. In the lungs, where oxygen is fresh and abundant, oxygen attaches to the iron. In tissues where oxygen is needed, it releases again. Bind and release. Bind and release. A calm exchange, repeating thousands of times as you move through hours. This is part of why breath feels so natural. You do not have to personally deliver oxygen to each corner of your body. Iron helps manage the delivery with quiet efficiency, like a careful courier who knows every street. Iron also has a broader story, stretching far beyond a bloodstream. Long before people smelted iron from ore, iron was being made in the universe. Heavier than carbon and oxygen, it forms deep inside large stars, under intense heat and pressure. In the final stages of a star's life, iron accumulates, and in some cases, the star ends in a dramatic scattering, sending iron outward into space. Over long time, that iron becomes part of planets. It sinks into cores, it appears in rocks, it waits. Then humans find it, heat it, shape it, and make spoons and tools, beams and bridges. And meanwhile, a little of that same element becomes part of you, circulating quietly, letting you carry oxygen from moment to moment. If you ever feel tired after a long day, you might think of iron and oxygen and the quiet partnership between them. Rest is not only a decision of the mind, it is also a rhythm of the body, a steady exchange of molecules and atoms. Tonight, as you lie still, your blood continues, calm and unhurried. Iron continues to bind and release. The work does not feel loud. It feels like the background hum of life, soft enough to ignore. And because it is so steady, you are free to drift. Even the color of blood is part of iron's presence. When oxygen is bound, the red is brighter. When oxygen has been released, it deepens, like dusk settling over a landscape. Some people keep a small magnet on a fridge door and feel the faint pull without thinking about it. Iron responds to magnets in that same subtle way, a reminder that elements can have personalities as well as purposes. Somewhere in the day, you make a small decision. You lift a finger, you blink, you swallow, you stand up, you reach for a door handle. Each of these acts feels simple, almost automatic, but beneath them is a quiet electrical language moving through your body. That language depends in part on two familiar elements, sodium and potassium. You may have heard of them in passing as names on nutrition labels, but tonight we meet them more gently as traveling messengers. Nerve cells carry signals by changing tiny differences in charge across their membranes. Imagine it as a calm shoreline with one side holding more sodium and the other holding more potassium held in careful balance. When a signal is needed, channels open briefly. Sodium flows in, the charge shifts, the message begins to travel. Then, just as quietly, potassium flows out, restoring the calm. It is a wave, but a very small one, a ripple moving along a nerve like a soft pulse along a wire. You do not feel sodium entering a cell. You do not feel potassium leaving. You only feel the outcome, movement, sensation, intention. Your body keeps these elements in steady circulation. Sodium is common in the outer fluids, in blood, and in the spaces between cells. Potassium is held more inside cells, kept there with gentle effort. A tiny molecular machine, working constantly, trades them back and forth, maintaining the difference like a quiet caretaker resetting a room after each visitor. This is why both elements matter. Too much of one, too little of the other, and the signals can lose their smoothness. Muscles may cramp. The heart's rhythm may feel off. The body, always seeking steadiness, pays attention to these small balances. And once again, these elements arrive through ordinary life. Salt on food, potassium-rich fruit, water moving through you, carrying ions along, a day's chemistry hidden in plain sight. Tonight, as you rest, your nerves become less busy. The messages slow, the muscles soften, the small electrical tides quiet down. Sodium and potassium continue their gentle exchange, but with fewer demands, fewer urgent instructions. It becomes background again, a steady, invisible support. And in that support, you can feel how the periodic table is not distant at all. It is in the simplest movement. It is in the calm that follows movement. It is in the way your body knows how to settle and let the night take over. If you have ever felt your heart beating in your chest, steady and regular, remember that it too listens to these small currents. The same quiet ions that help a finger lift also help a heartbeat keep time, patiently, through the night. As afternoon light begins to soften, you may notice the sun in a new way, not as a bright disk to stare at, but as warmth on skin, a slow glow on walls, and shadows that lengthen without urgency. The sun feels familiar, and yet it is the largest chemistry story in your day. Deep inside it, hydrogen is gathered under immense pressure. Hydrogen atoms, the simplest of all, are pressed so close that they can join, becoming helium. In that joining, a tiny amount of mass turns into energy, released as light and gentle heat, flowing outward for a very long journey. By the time it reaches your window, it has quieted into something you can live with. Long ago, before anyone knew the word fusion, people still felt the same truth, that daylight is not merely brightness, but a steady supply of warmth that makes the world workable. Plants lean toward it, streets dry after rain, and your body, without asking, finds comfort in it. In the 19th century, scientists began to read sunlight more carefully. When sunlight is split into a spectrum, it shows thin lines, like a delicate barcode, each line revealing which elements are present. One line did not match anything known on Earth, and it led to the discovery of helium, named for the sun before it was found in our own rocks. Even the sky's color is part of this quiet physics. Sunlight carries many colors together, but the air scatters the shorter, bluer light more easily, spreading it across the dome above you. Near sunset, when light travels through more atmosphere, the blues scatter away and warmer tones remain, and the day starts to feel slower. This light also connects to the rest of your element, day. In leaves, carbon dioxide from the air meets water drawn up from roots, and with sunlight as the calm driver, the plant builds sugars and releases oxygen. The oxygen you breathe in tonight may have been released by a tree earlier this week, and the carbon you breathe out may, in time, become part of a leaf. So, the sun is not only warmth, it is a steady exchange. Hydrogen changing, light traveling, oxygen returning, carbon cycling, all without hurry. And when late afternoon arrives, you can see that steadiness in small details. Dust floats through a beam like slow stardust. A curtain warms and settles. The room holds a softer brightness, as if the world has begun its evening exhale. Far beyond our day, stars are where many heavier elements are made. Carbon, oxygen, iron, and more are formed over long ages and sometimes scattered outward when a star ends, seeding future worlds with stardust that later becomes stone, water, and bone. You can follow that exhale now, letting your own thoughts loosen and letting the light fade at its natural pace. By afternoon, you may find yourself outside, even briefly. A hallway, a parking lot, a sidewalk, a street corner where light falls onto ordinary surfaces. The built world has its own set of everyday elements, arranged into materials that feel dependable and solid. Aluminum is one of the quiet stars of modern life. It is light in the hand, resistant to rust, and easy to shape. It appears in window frames, in foil, in drink cans, in ladders, in parts of cars and airplanes. Aluminum begins as a mineral locked in rock, and extracting it takes a great deal of energy. Once it is made, it can be melted and remade again and again with far less effort. Concrete is everywhere beneath your feet, and it is less a single substance than a calm mixture. Cement, sand, gravel, and water join together, and as it sets, calcium-rich compounds form tight bonds, turning a wet paste into stone-like strength. Hidden inside many slabs is iron, often as steel rebar, giving concrete the ability to handle pulling forces without cracking. The pairing is almost poetic. Concrete is strong when squeezed, steel is strong when stretched, and together they hold up the everyday world. And then there is the dark ribbon of asphalt, a surface that holds heat and carries sound. Asphalt relies heavily on carbon-based materials, thick residues from ancient organic matter, mixed with stone to form a road that flexes slightly under weight and weather. If you listen as you walk, each material has its own voice. Concrete answers with a dull firmness. Asphalt sounds softer, more muted, as if it absorbs the world's sharp edges. Metal railings ring briefly when tapped, a clean note that fades. Even the dust on a curb is a reminder of oxygen's quiet reach. Most rocks are made of oxides and silicates, where oxygen binds with metals and with silicon, creating the minerals that become sand, clay, and stone. These are not separate worlds from the periodic table. They are the periodic table, arranged into familiar shapes. Aluminum's lightness, calcium's bonding strength, silicon's presence in stone, carbon's dark resilience, all working together so your day can move smoothly. And when you return indoors later, the elements will come with you, unnoticed, steady, waiting in the quiet objects that make up a home. For now, you can simply feel the ground underfoot and let it be enough. Look closely at a metal sign or a railing, and you may see a film that formed over time, a patina, a faint dulling, a change in color. That is oxygen again, ready to join and reshape surfaces, sometimes weakening iron into rust, sometimes protecting aluminum with a tight, invisible layer. Bricks, too, carry the element story. Many are rich in silicon and aluminum from clay, baked with heat until the particles lock together. A wall, a curb, a step. Each one is a quiet arrangement of the same few building blocks. As the day carries on, the world outside begins to feel alive in quieter ways. A patch of soil, a line of trees, a potted plant on a balcony, all of them are busy, even when nothing seems to move. Here, nitrogen returns, not only as air, but as nourishment. Most living things need nitrogen to build proteins, the working molecules of life. But there is a gentle puzzle. The atmosphere is full of nitrogen, and yet most plants cannot use it in that airy form. The nitrogen in the sky is stable, content to drift. So nature relies on intermediaries. In the soil, certain bacteria can take nitrogen from the air and convert it into forms plants can absorb. Other bacteria do the opposite, returning nitrogen back to the atmosphere, closing the loop. It is a slow, quiet cycling that happens beneath your feet, out of sight, like a calm conversation between earth and sky. You can imagine it as a long exchange. The air offers abundance. The soil offers transformation. Plants take what they need, building leaves and stems, seeds and fruit. Animals eat the plants and carry nitrogen onward. Then, through time, the nitrogen returns. Humans join the story, too. Over the last century, people learned industrial ways to fix nitrogen, making fertilizers that helped feed billions. That achievement came with trade-offs because too much fertilizer can wash into waterways, encouraging algae to bloom and upsetting the quiet balance of lakes and coasts. So nitrogen is both gentle and powerful. It is the soft majority of the air, and it is also a building block of growth. Tonight, we don't need to judge the modern story. We only need to notice the older one. Air and soil passing nitrogen back and forth, a leaf unfolding, a root drinking. Sometimes nature fixes nitrogen with a flash. Lightning can split nitrogen molecules in the air, allowing them to combine with oxygen and eventually fall to the ground in rain, a gift from storm to soil. And certain plants, like peas and beans, host helpful bacteria in little nodules on their roots, as if they have made agreements underground, trading sugars for nitrogen. If you have ever noticed how the smell of rain seems to wake the earth, you can imagine these exchanges continuing, drop by drop, grain by grain. A world that knows how to recycle what it needs. And in that slow recycling, there is a kind of comfort, the sense that growth is supported by patient chemistry, working steadily whether we watch it or not. And when evening comes, nitrogen will still be there, calm and plentiful, holding the sky in place above your resting room. As afternoon light begins to soften, you might notice the sun in a new way, not as a bright disk to stare at, but as a warmth on skin, a glow on walls, a slow turning of shadows. The sun feels familiar, and yet it is the largest chemistry story in your day. At the sun's heart, hydrogen is gathered under immense pressure. Hydrogen atoms, the simplest of all, are pushed so close together that they can join, forming helium. In that joining, a tiny amount of mass becomes energy, released as light and heat. It happens continuously, quietly, at a scale too large to imagine, and yet the result arrives gently as a calm brightness on a floor. This is where many elements begin their deepest story. Stars start with hydrogen and helium, and over long time they build heavier elements in their interiors. Carbon, oxygen, and beyond are formed in stellar furnaces, and in certain endings, when massive stars collapse, those elements are scattered outward, becoming part of future worlds. The idea can feel grand, but it does not need to feel intense. You can hold it lightly. The warmth on your hands is, in a way, hydrogen changing its form, far away, without hurry. Long before helium was found on Earth, it was first noticed in sunlight. In the 19th century, scientists studying the sun's spectrum saw a line that did not match known elements, and they named the new one for the sun itself. Even the color of the sky is part of this gentle physics. Sunlight carries many colors together, and the air scatters the shorter, bluer light more easily, spreading it across the dome above you. Near sunset, when light travels through more atmosphere, the blues scatter away and warmer tones remain, making the edges of day feel slow. That light is also an invitation to plants. In leaves, carbon dioxide from the air meets water drawn up from roots, and with sunlight as the gentle driver, the plant builds sugars while releasing oxygen back into the atmosphere. It is another quiet loop in your day. The same oxygen you breathe out can, over time, become part of a leaf, and the oxygen you breathe in may have been released by a tree days ago. So, the sun is not only warmth, it is connection, a slow engine that links hydrogen in stars to oxygen in air, carbon in wood, and the ordinary food that becomes you. In late afternoon, this can feel almost visible. Light slants through branches, and dust floats in the beam like tiny planets in orbit. The brightness is less demanding, the colors more muted, as if the world is beginning its own gentle exhale. You can let that exhale guide you too. As the day begins to lean toward evening, you might notice the sky again. Clouds, if they are there, move slowly, changing shape without effort, like thoughts drifting past when you do not hold on to them. A cloud is mostly water, returning to its lighter form. The same elements from your morning glass, hydrogen and oxygen, have been traveling all day, rising as invisible vapor from oceans, lakes, soil, and breath. Warm air can hold more water vapor, and when that air cools, the vapor condenses into tiny droplets, so small they can float. Each droplet is a miniature world, a bead of H and O, held together by quiet attraction. Light scatters through those droplets, turning the cloud bright at its edges, gray at its center, sometimes pink or violet near sunset. The color depends on the path of light through air and moisture, on distance and angle, on the slow geometry of evening. Sometimes you can smell rain before it arrives. The air changes, the world feels washed, and the surface of things seems to wait. When rain finally falls, it carries the day's elements back to the ground, water returning to soil, to plants, to pipes, to rivers, to the long circulation that never truly stops. And even on dry days, the movement continues. Water evaporates quietly from a kettle, from a shower, from a cup left near a window. It is there in the softness of your breath, leaving your mouth and nose as warm vapor. It is there in the faint humidity of a room, changing how skin feels, how fabrics settle, how sound carries. In a calm way, water connects inside and outside. It passes through you, and it passes through the world. And because it is so familiar, it can be easy to forget that it is also a precise relationship. Two light hydrogens bound to one oxygen, the simplest daily trio. If you want, imagine your day as a loop traced by that trio. Morning water, afternoon clouds, evening tea, night breath. a small set of atoms moving through many forms, always returning, always repeating, like a lullaby the planet has been singing for billions of years. As you look up, or simply picture the sky in your mind, let the thought be gentle. The elements are not only in objects and tools, they are in weather, in softness, in the slow motion of clouds as the day grows quieter. Water has a few gentle quirks that make it especially suited to life. Its molecules are slightly uneven, which helps droplets form, helps water rise through plants, and helps it dissolve salts, carrying tiny charged particles through your body and through the sea. So when you picture a cloud drifting or a raindrop beating on glass, you are seeing hydrogen and oxygen not only existing, but behaving, forming soft patterns the world relies on. Evening brings a familiar glow, a small rectangle of light that can feel louder than it is. Your phone rests on the table dark until you wake it, and when it brightens, it offers a last stream of attention, like a doorway that is easy to step through. Inside that thin object, the element story becomes modern and precise, yet still made from the same ordinary pieces you met all day. Silicon is at the heart of it. Silicon begins as sand, as pale grains on a beach, as dust in stone, as quiet mineral scattered across the earth. When silicon bonds with oxygen, it becomes the backbone of many rocks, and it can become glass, clear and still, holding daylight in a window. But when silicon is purified and shaped with care, it can behave in a different way. It can guide electricity, not as a flood, but as a controlled trickle, opening and closing pathways like a calm series of gates. On a chip, silicon is laid out in flat, smooth layers and then etched into patterns so small they seem like a kind of modern lace. Tiny pathways, tiny junctions, repeating again and again. The chip does not think, not in the human sense. It simply performs an enormous number of very simple decisions, quickly and consistently, the way a metronome keeps time without emotion. To make silicon behave just right, engineers add traces of other elements in almost invisible amounts, like a faint seasoning, just enough to change its character, just enough to make it more willing to carry charge or more willing to hold it back. A few atoms here, a few atoms there, and the whole landscape shifts. This is one of the quiet lessons of the periodic table. Small differences can matter. A single proton changes an element's identity. A tiny trace changes a material's behavior. The screen itself is another quiet collaboration. Glass again, strengthened, smoothed, layered, sometimes with coatings that resist fingerprints, sometimes with thin, transparent conductors that can sense the touch of your hand. Your fingertip, warm and slightly conductive, alters the electrical field just enough for the phone to notice. A gentle meeting between your body's chemistry and the devices. Silicon from sand, oxygen and glass, carbon in polymers that feel soft and light, aluminum in the frame that holds everything steady, copper in delicate traces that carry current like silent roads. All of it arranged so that a glow appears and disappears with almost no effort from you. If you listen closely, the phone has its own quiet sounds. A soft tap, a faint buzz, the tiny click of a button. Small reminders that the modern world is still physical, still built from matter, still dependent on atoms behaving as they always have. And now, as the evening deepens, you can let that glow become less persuasive. You can let the phone rest the way a stone rests. The elements inside it continue their quiet potentials, but inside that same phone is a small reservoir of stored motion, a calm place where energy waits, a battery. We speak of batteries as if they are purely modern, but they are another old story in a new form. Elements willing to trade, willing to move, willing to settle. Lithium often plays the starring role. Lithium is a light metal, one of the simplest elements after hydrogen and helium, and it has a particular eagerness to give something away. That eagerness is not a personality, not truly. It is a tendency, a quiet habit of its atomic structure, the way a person might naturally speak softly or walk quickly. Lithium likes to become a lithium ion, a tiny charged traveler. In a lithium-ion battery, these travelers move back and forth between two sides. When the battery is charging, lithium ions settle into one side, tucked away, stored, waiting. When the battery is used, they drift back toward the other side, and as they do, electrons flow through the circuit outside, creating the useful work you notice: a screen lighting, a song playing, a message arriving. It is a loop that feels almost like breathing. In one direction, the system fills. In the other, it releases. Never all at once, always in portions. This is why a battery can feel comforting in a strange way. It does not demand a sudden burst. It offers a steady stream, a controlled release. And that control comes from structure, layers inside the battery that keep the reactions orderly, preventing everything from happening at once. Other elements join the story, too. Carbon often appears in graphite, forming one of the battery's layers, a gentle host that can hold lithium ions between its sheets. Metals and minerals appear in other parts, chosen for how they accept and release charge, chosen for how stable they remain through many cycles. You do not need to memorize names, just notice the pattern. Elements are chosen not for drama, but for consistency. Lithium is gathered from the earth in scattered places, sometimes from salty brines, sometimes from hard rock, sometimes from deposits that took long eras to form. Its extraction and use have become part of a wider modern conversation about energy, transport, and technology. That larger story can be noisy. Tonight, we keep the sound low. Tonight, we simply recognize a small, light element quietly moving back and forth, doing its work without needing to be seen. And as you prepare for sleep, you can borrow that rhythm. Charging is not required. Productivity is not required. You can let the day's stored energy release gently in small amounts until it is time to rest. If your phone is plugged in, the tide turns again. Lithium returns. Energy stores. If it is not, the battery simply waits. Either way, the elements are patient. They do not rush. They do not worry. They move when conditions invite them, and they settle when the night becomes still. And you can do the same. In the walls of your home, behind furniture, inside cords and chargers, there is another element carrying the modern world with quiet reliability. Copper. Copper has a warmth that feels almost human, not just in its color, but in the way it seems to belong in the hand. It can be shaped and bent with ease, drawn into thin wire, twisted, coiled, tucked into places you never see. And it conducts electricity with remarkable smoothness, letting electrons move through it as if the path is gentle and open. Long before anyone spoke of circuits, copper was already part of daily life. People found it as a native metal, sometimes pure enough to hammer without smelting, and they learned to mix it with tin to make bronze, changing the strength and the feel of tools. In that older world, copper was a material of bowls and ornaments, of coins and small fittings, of practical beauty. In the modern world, it is everywhere, mostly hidden. It is behind the socket where you charge your phone. It is inside the lamp that makes evenings soft. Copper is a quiet pathway, like a riverbed that guides flow without asking to be thanked. Over time, copper changes on the surface. If you have seen old copper roofs or statues, you may have noticed the green-blue patina that appears. That patina is a collaboration between copper, oxygen, and moisture. A thin outer layer that forms and then protects what lies beneath. It is another example of the world's preference for balance. Surfaces adjusting until they become stable. Electricity itself can feel abstract, but it is made of real particles moving through real materials, and copper is one of the most welcoming roads they can take. When you switch on a light, electrons begin their calm travel. When you switch it off, the travel stops and the copper remains, silent and ready. There is a comfort in that readiness, without insistence. Copper holds potential without demanding that you use it. It does not hurry you. It simply waits. And if you listen closely at night, you might hear faint signs of this hidden network, a soft click as a device changes state, a gentle hum from a refrigerator, a tiny buzz from a charger, small sounds that remind you the house is alive in the background even as you become quieter. Copper, too, has an older origin. It was formed in stars, in long stellar lifetimes, and scattered outward, then gathered into rocks, then drawn out by human hands and made into wire. Stardust shaped into a household convenience. And now, as your evening settles, you can choose what to quiet You can turn off the lamp. You can set the phone aside. You can let the bright pathways step back. Copper will remain content to hold stillness. It is a useful lesson for the mind. Thoughts can exist without being followed. Energy can exist without becoming action. The day can exist behind you while the night arrives in front of you, calm and unhurried. Now, with evening steady around you, we can glance at the periodic table itself, not as a lesson, but as a gentle map you have already walked. You have met its residents today without needing to look them up. Nitrogen and oxygen in your breath, hydrogen and oxygen in water, sodium and chlorine in salt, iron and steel and blood, calcium in bone, phosphorus in quiet energy work, silicon in glass and screens, lithium in a battery, copper in wire. The table gathers these names into an arrangement that feels almost soothing because it is orderly, and the order reflects repeating patterns in how atoms tend to behave. Across the table in rows, elements become heavier, one step at a time, adding protons, changing identity in a steady count. Down the table, in columns, elements share certain tendencies as if they have similar manners. Some are eager to give something away, like sodium. Some are eager to receive, like chlorine. Some prefer to remain complete and calm, like the noble gases, drifting through the world without much reaction, content with their balance. These repeating tendencies come from how the smaller parts of atoms arrange themselves around the center in layers that can be filled. When a layer is nearly empty or nearly full, an element often becomes more reactive, seeking stability through partnership. But you do not need diagrams tonight. You can recognize the patterns through feeling. Salt, stable and safe, born from two unruly elements finding balance. Iron, strong but willing to change, turning to rust when oxygen patiently joins it. Oxygen, supportive and active, feeding both breath and flame. Silicon, sometimes still as glass, sometimes lively as a controlled pathway for current. The periodic table is a record of these quiet preferences, and one of its most peaceful qualities is that it can predict. In the past, people noticed gaps, spaces where an element should exist if the pattern was true. They left room. Later, new elements were found that fit those spaces, like missing puzzle pieces returning to the picture. So, the table is not only a list of what we know, it is a structure that hints at what must be true even before we see it. Tonight, though, we keep our attention close and ordinary. We let the table be a reassurance that the world is not endless chaos. It is composed. It repeats. It follows rules that are steady enough to lean on. You do not have to master those rules to benefit from them. You can simply feel the comfort of being in a universe that has order built into its smallest parts. A small number of building blocks, arranged and rearranged, making breath, water, bone, wire, window, and sky. The day becomes less mysterious in a calming way, not because it is fully explained, but because it is quietly consistent. And inside that consistency, you are allowed to let go, to stop counting, to stop managing, to rest. And now the story returns, gently, to where it began, to your breath and to the stillness of the room. The day has been full of elements, but they were never separate from you. They were the taste of salt, the coolness of water, the firmness of bone, the quiet work of blood, the soft glow of a screen, the calm reliability of a lamp. They were the ordinary materials that carried you through ordinary hours. Everything is made of these building blocks, not many, a manageable number arranged in an orderly way, like a small alphabet that can form countless words. Your body is a quiet library of elements. Oxygen, moving through lungs and blood, carbon forming frameworks in cells and skin, calcium holding shape in bones and teeth, phosphorus helping energy arrive where it is needed, then moving on, sodium and potassium keeping a gentle electrical balance so muscles can relax and the heart can keep time. Iron offering its patient handshake to oxygen again and again without complaint. Outside, the same elements continue their wider motions. Water drifts, gathers, falls, and rises again. Nitrogen cycles through soil and leaf, then returns to the air. Oxygen joins with stone and metal, then travels onward. Carbon moves between breath and tree and earth, looping softly through life. And far beyond, stars continue their slow work, turning simple hydrogen into heavier possibilities, scattering stardust that will one day become something ordinary again. Sand beneath feet, iron in tools, calcium in cliffs, copper in wire. It is a comforting loop. The cosmic becomes familiar. The familiar returns to the cosmic. Some nights, it helps to picture the periodic table as a quiet shelf of jars, each one holding a different kind of matter. Some jars feel almost weightless, like hydrogen. Some feel grounded, like iron. Some carry a soft usefulness, like oxygen and carbon and silicon, appearing everywhere once you learn their names. However you picture it, let it be reassuring. The night does not require understanding. It only requires permission to soften. So take a slow breath in. Let it pause just briefly, then let it go as gently as a cloud loosening from the sky. You have moved through an ordinary day made calmer by its hidden order. And now you can let that order hold you without effort, without expectation. Nothing to do, nowhere to go, only rest. Good night.